Something is happening in the world right now that most people barely understand. Not because it's hidden, not because it's classified, but because almost nobody is explaining it in a way that makes sense to ordinary people. So today, that's exactly what we're going to do. Right now, Iran, a country that has been sanctioned, isolated, and cut off from much of the global technology market for decades, possesses missiles and drones capable of confusing, overwhelming, and sometimes even defeating some of the most expensive air defense systems ever built. And the single biggest reason this became possible is China, not through dramatic weapons deals, not through a formal military alliance, but through something much quieter, much slower, and far more powerful, a gradual, almost invisible transfer of technology that has been unfolding for years, right in front of the world, while most people simply look the other way. That is the story we're going to explore today. And by the time we finish, you will probably never read a headline about Iran's military capabilities the same way again. To understand how we got here, we have to go back to where the story truly begins: the Iranian Revolution. Overnight, Iran's relationship with the West collapsed. And that created a massive problem for the Iranian military, because almost every major weapon system they owned came from the United States. Their fighter jets, their tanks, their missile systems, all American. And the moment the revolution happened, the entire support system behind those weapons disappeared. Spare parts? Gone. Technical support? Gone. Upgrades, manuals, training? All cut off by sanctions. Then, only a year later, in 1980, the Iran-Iraq War began, and Iran suddenly found itself fighting a brutal war with weapons it could barely maintain. Equipment broke down faster than it could be repaired. Aircraft sat grounded, missile systems failed, and tens of thousands of Iranian soldiers died in battles where their weapons simply could not keep up. That experience left a permanent scar on the Iranian military leadership, a lesson they would never forget. Never again depend on foreign suppliers for your survival. Build your own weapons, design your own systems, and if you cannot build the most advanced version, then build something cheaper, something simpler, something you can produce in massive numbers. That decision, born out of desperation in the 1980s, is the foundation of the Iran we see today. Now, here is where most people misunderstand the story. When people imagine China helping Iran's military, they picture secret arms shipments, cargo ships in the night, crates of weapons being smuggled across borders. But that's not what really happened. What China provided Iran was something far more valuable than weapons themselves: knowledge, engineering knowledge, technical expertise. And that difference matters enormously. A weapon can be destroyed, a shipment can be intercepted, a factory can be bombed. But knowledge, once scientists and engineers understand how to build something, you cannot erase that knowledge. You cannot sanction it away. You cannot intercept it at a border. And over the years, Iran absorbed exactly that kind of knowledge: propulsion technology, guidance systems, advanced materials, drone design, manufacturing techniques. Iranian engineers studied it, adapted it, modified it, improved it, and slowly built a domestic military-industrial capability that would have seemed impossible for a heavily sanctioned country 20 years ago. Let's talk about one specific area where this transformation is especially important: missile propulsion. Because when it comes to ballistic missiles, there are two main types of fuel systems: liquid fuel and solid fuel. Liquid fuel missiles are powerful, but they have a major weakness: they must be fueled right before launch. That process can take hours. In modern warfare, hours is an eternity. Satellites can detect the fueling activity. Enemy aircraft can strike the launch site. The missile can be destroyed before it ever leaves the ground. Solid fuel missiles are completely different. They are stored ready to launch. No fueling required, no preparation time. You can hide them inside tunnels, inside mountains, on mobile trucks, and launch them within minutes, which means the warning window for your enemy is almost zero. For many years, Iran struggled to develop solid fuel missile technology. It's extremely difficult. The chemistry is complex. The materials must withstand incredible stress. The manufacturing precision required is very high. But over time, with assistance from Chinese technical knowledge, materials, and components, Iran made enormous progress. Over the last decade, Iran's transition towards solid fuel ballistic missiles has accelerated dramatically. And that shift represents a major strategic change, because it means Iran can now launch missiles with almost no warning at all. But missiles are only half of the story. The other half is drones. And one drone in particular has changed modern warfare more than most people realize: the Shahed 136. You may have heard the name in the news. If not, it's worth remembering, because this small drone has become one of the most strategically disruptive weapons of the 21st century. A Shahed 136 costs somewhere between $20,000 and $50,000 to produce. It flies low to the ground, making radar detection difficult. It can travel over 1,000 kilometers, and it carries an explosive warhead capable of damaging critical infrastructure. Power stations, radar installations, fuel depots. But the real power of this drone is economic. To shoot down one of these drones, a modern air defense system often fires an interceptor missile. Those interceptors can cost anywhere from $500,000 to several $1,000,000 each. So the math becomes brutal. A $50,000 drone destroyed by a $1,000 missile. Multiply that across hundreds of drones, across repeated attacks, across months and years, and the defender starts bleeding money, while the attacker simply keeps producing more drones. That imbalance is not a flaw in the system. It is the entire strategy. And once again, Chinese supply chains have played a role. Investigations by journalists and research organizations have traced components inside many of these drones, engines, navigation chips, electronics, back to Chinese manufacturers. Many of those components are technically civilian products, but in the hands of Iranian engineers, they become parts of a weapon system. Western sanctions block access to many high-end technologies. Chinese supply chains are far more accessible, and whether intentionally or through lax enforcement, those components continue to reach Iran. But everything we've discussed so far may soon be the least dangerous part of the story, because the next evolution is already underway. Artificial intelligence, autonomous drones, and coordinated swarm attacks. Let's explain what that actually means. An AI-enabled drone doesn't simply follow a pre-programmed route. It can analyze what it sees, identify potential targets, adjust its flight path, avoid obstacles, and decide when to strike, all without direct human control. Now imagine not one drone doing this, but hundreds, 300 drones flying together, communicating with each other, dividing targets among themselves, approaching from multiple directions at the same moment. That is what military planners call a swarm attack. And swarm attacks are specifically designed to overwhelm traditional air defenses, because those defenses are built around a basic assumption that threats can be detected and intercepted individually. A coordinated swarm destroys that assumption. The final piece of this evolving strategy is electronic warfare. Modern air defense systems rely on sensors, radar, infrared tracking, electronic surveillance, all working together to detect incoming threats. But all of those systems depend on electromagnetic signals, and electronic warfare manipulates those signals. Radar can be jammed, GPS signals can be spoofed, fake targets can be created, intercept missiles can be tricked into chasing ghosts, while the real attack slips through. China is one of the global leaders in electronic warfare technology, and Iran is studying those techniques closely, which leads to the obvious question: why would China help Iran build these capabilities? After all, China buys massive amounts of oil from the Middle East. China has invested billions in regional infrastructure. Instability seems like it would hurt those interests. So why risk it? Because China is playing a much longer strategic game. Every crisis in the Middle East that demands American military attention is a crisis that pulls American focus away from the Pacific, away from Taiwan, away from the South China Sea, away from the region where China's real strategic competition with the United States is unfolding. From Beijing's perspective, Iran can function as a remarkably cost-effective distraction. A relatively small investment in technology transfers can allow Iran to impose enormous strategic and financial costs on American allies in the region. That is leverage, and it is leverage China has been quietly building for years. So what does all of this add up to? For decades, Western military strategy in the Middle East relied on one core assumption: that technological superiority would remain overwhelming, that no regional adversary could seriously challenge it. But that assumption is slowly changing, not because Iran is matching Western technology system for system. That was never the goal. Instead, Iran is developing capabilities designed to undermine the specific advantages Western militaries depend on: precision weapons that eliminate distance, low-signature drones that evade radar, swarm tactics that overwhelm defenses, electronic warfare that blinds sensor networks. Each of these tools is dangerous on its own. Together, they form a doctrine based on a simple insight. You do not need to win a war outright to achieve your strategic goals. You only need to make the cost of opposing you so high, so continuous, and so economically draining that eventually your opponent decides the fight is no longer worth it. The engineers studying these systems understand this. The intelligence analysts tracking the components understand it. The military planners modeling future conflicts understand it. They are watching this transformation happen in real time, drone by drone, missile by missile, capability by capability. And the uncomfortable truth, the conversation that many governments are still hesitant to have openly, is this. The era of easy technological dominance in this region may be ending. Not with a dramatic moment, not with a single decisive battle, but slowly, quietly, piece by piece, until one day, somewhere inside a command center, someone looks at the screen and realizes the math has changed. The shield now has more holes than interceptors, and the advantage that once seemed permanent has been carefully, patiently dismantled, so continuous and so economically draining that eventually your opponent decides the fight is no longer worth it. The engineers studying these systems understand this. The intelligence analysts tracking the components understand it. The military planners modeling future conflicts understand it. They are watching this transformation happen in real time, drone by drone, missile by missile, capability by capability. And the uncomfortable truth, the conversation that many governments are still hesitant to have openly, is this. The era of easy technological dominance in this region may be ending, not with a dramatic moment, not with a single decisive battle, but slowly, quietly, piece by piece, until one day, somewhere inside a command center, someone looks at the screen and realizes the math has changed. The shield now has more holes than interceptors, and the advantage that once seemed permanent has been carefully, patiently dismantled.